Among Isaac Newton's private papers, researchers found a number that still unsettles people today, 2060. Some called it the date of the end of the world, but beside that calculation were stranger documents. Recipes for transforming matter, drawings of Solomon's temple, and religious arguments that could have cost England's greatest scientist his position and freedom. All of them were written by the same man who gave the world the laws of motion and universal gravitation. For almost 200 years, the public knew only half of Newton's story. The rest was scattered through private collections, locked boxes, and manuscripts few people wanted to read. So what was hidden in those papers? The breakdown of a brilliant mind, a secret belief that science could never accept, or an idea so large that Newton never found a safe way to explain it? This is not another story about a falling apple. We will follow 3 clues, one hidden in Newton's laboratory, one ending with the year 2060, and one buried inside the plan of a temple destroyed thousands of years before he was born. They seem to belong to 3 different men, a scientist, an alchemist, and an interpreter of prophecy. But by the end, they will fit together and reveal why Newton's legacy was split in 2. One half became a monument, the other was pushed out of history. Isaac Newton died in March 1727. By then, he was a national symbol. He had served as president of the Royal Society, directed the Royal Mint, and written a book that transformed humanity's picture of the universe. He was buried in Westminster Abbey, among the most honored figures in Britain. And it seemed that his biography was complete, but the real mystery was only beginning. Newton left an enormous mass of papers. Some contained scientific work. Others revealed activities he had kept almost entirely private. He copied alchemical recipes, compared biblical prophecies, calculated the dimensions of an ancient temple, and tried to prove that Central Church teachings had been altered over time. The papers passed between owners, and some disappeared into private collections. For generations, the public saw Newton as the perfect champion of reason, while another Newton remained buried in his manuscripts. In 1936, many of those papers were offered for sale in London. More than 2 centuries had passed since Newton's death, and his name had become almost synonymous with science. There was no unknown law of physics written clearly on the first page, no final equation explaining gravity, only obscure symbols, theological arguments, ancient chronology, and page after page of experiments with strange substances. The economist John Maynard Keynes acquired a large group of them. As he read, he found a man unlike the marble genius of schoolbooks. Newton, he concluded, was not only a founder of modern science, he was also one of the last magicians. That description creates a problem. If Newton was merely a superstitious alchemist, how did he construct one of the most precise systems of thought in human history? The answer begins with a force that no one could see. Newton showed that the same force could make an apple fall and keep the moon in orbit. Earth and the heavens no longer followed separate laws. Planets, moons, projectiles, and falling bodies became parts of one system. But gravity acted across distance. 2 objects could be separated by empty space and still respond to one another. There was no visible rope and no obvious substance pushing them together. Newton could calculate gravity, but not fully explain its nature. What carried its influence through empty space? Why should distant matter react at all? While studying the invisible force governing planets, Newton pursued another investigation behind a closed door. In a laboratory filled with furnaces, crucibles, metals, acids, and mercury, he heated metals, combined chemicals, and watched mixtures change color and texture. Some processes lasted hours or days, and he recorded every small change. Alchemical texts were deliberately obscure. Writers hid substances behind lions, dragons, kings, and planets. The sun might mean gold, the moon silver, and a green lion, a substance or stage of transformation. Newton copied different versions of these works, compared them, and searched for repeated patterns. He behaved less like a dreamer waiting for a miracle and more like a codebreaker reconstructing a lost technical language. Gold may not have been his true goal. His notes return to a deeper question. Why can matter combine, separate, attract, repel, grow, decay, and change form? This was the first clue. Newton was not simply searching for a magical substance, he was searching for the hidden mechanism that made matter active, and at some point, this search may have begun to damage him. And in 1693, something happened to Newton. He almost stopped sleeping. He became suspicious of friends. He wrote harsh, confused letters and accused people close to him of intentions they probably did not have. He suggested that John Locke had tried to involve him with women. He told Samuel Pepys that he no longer wished to see him. Later, Newton apologized and admitted that he had been in an extremely disturbed condition. What caused the crisis? Possible explanations include exhaustion, insomnia, the breakdown of his relationship with Nicholas Flamel, and long exposure to mercury and other toxic substances. No theory explains everything. Afterward, Newton's life changed. He moved away from the isolated laboratory, relocated to London, and entered government service. It was almost as though he had spent decades approaching a boundary his mind could no longer safely cross. Yet the laboratory was only the first clue. The second was a number that survived him. Newton spent decades studying biblical prophecy. He compared translations, examined ancient kingdoms, calculated the lengths of wars, and tried to arrange religious history into a measurable sequence. In one manuscript, his calculations led to the year 2060. Today, 2060 is often presented as Newton's date for the end of the world, an irresistible headline about the man who calculated both planetary motion and the apocalypse. But Newton probably meant something more complicated. He did not clearly say that Earth would be destroyed in 2060. He was attempting to identify the possible end of a vast historical era followed by a new order. Not necessarily annihilation, but transformation. Why would a mathematician who predicted celestial motion believe history also contained a hidden numerical structure? Religious obsession is the easy answer, but Newton did not merely study prophecy. He also concealed his own beliefs with great care. Newton believed the doctrine of the Trinity had been corrupted and that certain teachings were later additions. He studied old biblical versions, church councils, and early theologians, searching for what he considered the original faith. In 17th century England, such ideas could destroy a career. For a professor at Trinity College, the danger was especially obvious. He kept these ideas private and treated religious history as he treated light, motion, and alchemical texts. The visible version might be misleading, and the original truth had to be recovered, but even this secret belief does not fully connect the laboratory to the year 2060. For that, we need the third clue, the strangest of all. Newton spent an extraordinary amount of time reconstructing the Temple of Solomon. The temple had been destroyed long before his birth, and its exact appearance was uncertain. Yet Newton studied ancient measurements, calculated the proportions of courtyards and chambers, compared descriptions, and produced detailed plans. Why would a man who transformed mathematics and physics devote himself to the dimensions of a vanished building? Because Newton suspected that the temple was more than architecture. He believed its proportions might preserve traces of an original order, a kind of ancient wisdom that had once been understood and later corrupted or lost. For Newton, the road to truth led in two directions: forward through experiment in mathematics, and backward through ancient texts, symbols, measurements, and the recovery of forgotten knowledge. A pattern was emerging. Newton did not trust later church interpretations. He did not trust obscure alchemical authors. He did not even trust other scientists when they challenged his claim to a discovery. Again and again, he searched for a pure truth hidden beneath distorted versions, and as he grew older, he became increasingly determined to control which version of truth would survive. He reacted badly to criticism. After Robert Hooke challenged his work on light, Newton reduced his public scientific activity for years. A disagreement was not merely an intellectual exchange for him. It could become a threat to the entire structure he had built. Later came the conflict with Gottfried Wilhelm Leibniz. Both men developed powerful methods of calculus, and a bitter dispute began over priority. Who had made the discovery first? Had one borrowed ideas from the other? The Royal Society investigated the matter, but Newton was president of the Royal Society. He influenced the report. helped shape its conclusions and defended his own position while sometimes remaining in the background. The man who had spent his life decoding other people's texts now possessed the power to write the official version of his own history. His ability to pursue an opponent became even clearer during his years at the Royal Mint. England was reforming its currency while criminal networks clipped, melted, copied, and counterfeited coins. Newton could have treated his position as a comfortable honor. Instead, he gathered testimony, recruited informers, compared contradictory statements, and reconstructed networks of criminals. His most determined opponent was William Challoner, an intelligent counterfeiter who attempted to accuse the mint itself of corruption. Challoner tried to make Newton look incompetent. Newton collected evidence until Challoner was convicted and executed. The violence belonged to the age, but Newton's method is striking. Once again, he faced a confusing system of signs, lies, hidden connections, and competing versions of reality. And once again, he tried to reduce them to one correct pattern. He approached crime as he approached light. He approached testimony as he approached alchemical texts. He approached history as he approached prophecy. But why were all these activities separated after his death? After Newton was buried, Britain needed a clear hero, not a man who rejected official religious doctrine, not an alchemist who spent years handling dangerous substances, not an interpreter of prophecy who calculated the beginning of a new age. Britain needed the founder of rational science, so the most useful part of Newton's legacy became the official biography. The laws of motion, the reflecting telescope, the experiments with light, and universal gravitation. Other manuscripts remained with relatives, passed to collectors, and stayed outside the familiar history of science. This did not require a single organized conspiracy. No secret committee had to meet in darkness and decide which truth to destroy. Something simpler happened. Each generation selected the Newton it wanted to remember. Everything that did not fit that image was placed to one side. The result was the illusion of two completely different men. By day, the perfect scientist, by night, the secret mystic. But the three clues suggest that this division may be false. The laboratory, the year 2060, the plan of Solomon's temple. Now they can finally be connected. What do the transformation of matter, the movement of history, and the proportions of an ancient building have in common? For a modern observer, almost nothing. For Newton, the answer may have been everything. He believed the world had not been created in chaos. Matter had hidden rules. The heavens had hidden rules. Light contained an internal structure that remained invisible until a prism separated its colors. Why should history be different? Why should ancient texts be different? Why should a sacred building be different? The alchemical laboratory was an attempt to uncover the code of matter. The calculation of 2060 was an attempt to uncover the code of history. The Temple of Solomon was an attempt to recover the code of original knowledge. Mathematics and physics revealed the code of motion in the heavens. Newton did not spend his days practicing science and his nights escaping into madness. He may have believed that all these activities led toward the same destination. He was trying to reconstruct the design according to which the world had been made. That is why his manuscripts are so difficult to fit into the familiar biography. They do not reveal a second Newton. They reveal one complete Newton whose mind belonged to two ages at once. With one foot, he stood in the future of modern science. With the other, he remained inside an ancient world of symbols, prophecy, hidden correspondences, and sacred design. So what did Newton's papers actually hide for almost 2 centuries? Not a proven formula for the philosopher's stone, not a precise description of the end of the world, and probably not one final scientific discovery. They concealed the origin of Newton's way of thinking. The modern world preserved his correct answers, but discarded many of the questions that led him toward them. We kept gravity, but forgot his obsession with invisible forces. We kept his work on light, but rejected his belief that lost knowledge might be recovered from ancient sources. We turned him into a symbol of science defeating mysticism, although Newton himself may never have accepted a clear boundary between them. Isaac Newton helped humanity enter a new scientific age, but until the end of his life, he remained partly a man of the older world, a mathematician who searched for meaning and prophecy, a physicist who spent nights beside an alchemical furnace, a scientist who tried to read the universe as an encrypted book. Perhaps that is why his legacy had to be divided, not because the archive contained one terrifying secret, but because the real Newton was too difficult to explain. And now the final question is no longer whether Isaac Newton believed in magic. The real question is this: how many great discoveries began with ideas that we would refuse to take seriously today?